Okay, let's try again. In each of our brains there are about 85 billion interconnected nerve cells called neurons. So imagine, let's put this into perspective. We were all here in the Rode Laars. We would be surrounded by about 50 million billion other people to make up the brain. So, what do all these neurons do? Neurons help us to facilitate our behavior. They help us falling in love, let us run a marathon, but they also make up our memories. But certain memories become too strong, for example in addiction. So, memories are represented by only a sparse number of these neurons. So only a few of them represent a certain memory. Oh, God. A potential therapy would therefore be to specifically target these neurons that represent the pathological memory. So, for example, those neurons that make you crave to drugs or cause relapse to drugs. But how to find this needle in the haystack? How to turn off only those neurons and not turn a patient into a tabula rasa? Recent advances in neuroscience may shed light upon this issue by using optogenetics. As you may infer from the term, they are using light to turn certain neurons on or off specifically. Only neurons that are active during a certain memory can be turned off or on because you can place an opsin, which is an algae-derived protein, in a neuron. So once you shed a laser light upon upon these neurons, they can be turned on or off. So what I'm currently doing in the lab, I'm making mice into cocaine addicts. I do that by giving them cocaine in a certain context and saline in another. When they have the option to choose in which room they want to reside, they of course choose the cocaine room. By exposing them to the cocaine room, I can tag those neurons that are active in the cocaine room and are therefore cocaine-associated neurons. Then, once I use my laser, I can specifically turn off these neurons. So this story not only holds true for addiction, but think about all those people, mainly soldiers, that suffer from post-traumatic stress disorder. What if you could, just by simply turning on the light, turn off their memory? So, in the future, optogenetics may be able to shed light on pathological memory disorders by specifically turning off that, and that neuron. Thank you.